Modern engineering operates under the assumption that nothing in the ocean is permanently out of reach. We can send remotely operated vehicles to the deepest trenches, we map historical shipwrecks in millimeter detail, and we routinely lift thousands of tons of steel from the seafloor. Yet there is a specific class of sunken warships and military vessels that governments do not try to raise whole. We leave their main wreckage where it fell, not because we lack every tool that could reach them, but because the very act of full recovery could make the danger worse. One of these wrecks still visibly holds a vast cargo of unexploded munitions just off a major coastline. Another leaks oil beneath a pristine white memorial, and another releases radioactive traces into the deep ocean. These are not just historical artifacts gathering dust in the dark. They are living hazards, proving that in some rare cases, the most advanced engineering choice humanity can make is not a dramatic salvage operation, but monitoring, containment, and restraint. The rusted, jagged masts of a cargo ship protrude directly out of the gray surface water of the Thames Estuary, flanked by bright yellow warning buoys. This is the visual reality of the SS Richard Montgomery, an American Liberty ship resting in the shallow waters off the coast of England. During a violent gale in August 1944, the ship grounded heavily on a shifting sandbank while awaiting a convoy. Liberty ships were constructed quickly for the war effort, and their welded hulls exposed a dangerous combination of wartime steel quality, stress concentration, fabrication defects, and cold water brittleness. Just days after running aground, the massive hull cracked and flooded before salvage crews could finish unloading its hold. The ship was a crucial part of the transatlantic supply chain feeding the Allied war effort in Europe, but today it is carefully avoided by every vessel navigating the busy commercial shipping lane. It remains trapped on the sandbank because its dark cargo holds still contain about 1,400 tons of explosive material. The munitions are unexploded and potentially dangerous after decades in salt water, and the physical boundary preventing their removal is the sheer scale of the kinetic risk. Extracting the heavily corroded bombs, fuses, and shells from the tangled steel would require delicate manipulation, and an accident could carry consequences far beyond the wreck itself. Worst-case assessments have raised concerns about blast damage and local wave effects in the shallow Thames Estuary, even as official monitoring describes a major explosion as a remote risk. To mitigate this risk, the Medway Ports Authority maintains a strict 24-hour radar watch over the exclusion zone, treating the visible masts as a permanent warning monument. The Richard Montgomery is avoided because touching it could cause an immediate kinetic disaster, but in a quiet Scottish harbor, another massive wreck was left on the bottom, not because of what might explode, but because of the law. A ghostly multi-beam sonar scan reveals the massive 600-foot hull of a warship resting entirely upside down on the dark sandy seabed of Scapa Flow. This inverted mountain of steel is HMS Royal Oak, a British Revenge-class battleship that was destroyed while anchored in what was supposed to be an impenetrable harbor. In October 1939, the German submarine U-47 slipped past the physical blockades and fired a spread of torpedoes into the anchored fleet. The Royal Oak capsized and sank in about 15 minutes, a catastrophically rapid loss, made worse by the way water poured through vulnerable openings while the ship lay at anchor in what had been treated as a safe anchorage. 834 men were lost in the sudden sinking, shattering the illusion of British naval invulnerability in their own home waters. Today, the ship sits just 90 feet below the surface, acting as a protected war grave that still contains difficult-to-reach fuel oil within parts of its structure. Under the Protection of Military Remains Act, the upside-down hull is a controlled site, meaning any engineering work must be licensed, limited, and designed around the moral boundary of the sailors still inside. The response evolved away from any idea of crude, large-scale salvage and toward carefully controlled pollution management. Eventually, marine engineers developed a complex workaround using a technique called hot tapping. They carefully drilled valves directly into the accessible outer hull tanks without breaching the sealed interior spaces, allowing them to pump out the most immediate threats. However, some of the most difficult inner spaces remain in place, protected for now by a combination of law, engineering caution, and the moral boundary of the men entombed inside. The Royal Oak is protected by strict military law, but half a world away, another battleship continues to leak oil every single day, and the government simply refuses to stop it. Rainbow-colored drops of oil slowly bubble to the water surface, pooling brightly directly beneath a pristine white architectural structure. This is the daily reality of the USS Arizona, an American Pennsylvania-class battleship, lying shattered in the shallow waters of Pearl Harbor. The ship was destroyed by an armor-piercing bomb during the surprise Japanese attack in December 1941. The bomb penetrated the forward decks and detonated the main ammunition magazines, instantly shattering the forward section of the massive warship. Because the battleship had been fully refueled the day prior to the attack, it went down holding roughly 1.5 million gallons of heavy fuel oil. Its destruction became the defining, tragic image of the event that brought the United States into the Second World War. Today, the submerged remains of the hull are often reported to leak around 2 to 9 quarts of oil each day, forming vibrant slicks on the surface known to many visitors as the Black Tears. The boundary preventing the Navy from simply draining the remaining fuel is not only symbolic and moral, but also archaeological, structural, and environmental. The National Park Service and the U.S. Navy treat the wreck as both a memorial and a fragile historic site, where any aggressive intervention could disturb the resting place of nearly 1,000 entombed sailors and risk damaging a hull already weakened by time. This respect for the dead dictates every engineering decision made at the site. When the sweeping white memorial was constructed, it was meticulously engineered to straddle the wreckage, suspended on heavy pilings so that it does not rest a single ounce of weight on the fragile, deteriorating hull. The deliberate choice to do nothing about the oil comes with a biological cost. Researchers have studied naturally occurring microbes, seawater chemistry, trapped oil, and sediment as part of the slow corrosion story. But the exact long-term breakdown of the steel is a complex process rather than a single simple chain reaction. The USS Arizona is deliberately left untouched out of respect for the dead, but deep in the North Sea lies a shattered wreck left alone out of fear for the living. A shattered submarine is split cleanly into 2 massive sections, resting quietly on the cold, sandy sediment of the North Sea floor. This broken machinery is U-864, a German Type 9 submarine sunk off the coast of Norway during the final months of the war. In February 1945, the submarine was conducting a highly secretive transport run known as Operation Caesar, meant to deliver advanced war materials and heavy metals to the Japanese weapons industry. It was intercepted by the British submarine HMS Venturer, resulting in a successful torpedo attack while both vessels were completely submerged beneath the surface, the only underwater kill of its kind in naval history. The violently compromised hull plunged to the seabed, taking its entire crew and a uniquely terrifying cargo with it. Today, the intensely corroded wreckage remains in place because it is surrounded by thousands of small steel flasks, believed to have carried roughly 65 to 67 tons of highly toxic elemental mercury. The physical boundary preventing governments from simply raising the submarine with heavy ocean cranes is the combination of structural fragility, buried debris, possible munitions, and contaminated sediment around the wreck itself. A recovery attempt could destabilize the wreck, disturb dangerous cargo, and spread the mercury the operation was meant to contain. This danger is compounded by a biological mechanism called methylation. Under the right conditions, elemental mercury can be converted into methylmercury, a toxic organic compound that can enter the marine food chain and accumulate in fish. Around the wreck, Norwegian authorities have treated the contaminated seabed as a long-term environmental risk, while monitoring has also shown that conditions in the open water near Fedje can limit how far that risk moves through seafood. Lifting a broken submarine is deemed too dangerous because of what it might spill, but further north, resting in total darkness, lies a submarine so inherently dangerous that no salvage equipment on Earth can safely bring it home. The glowing lights of a remotely operated vehicle cut through the absolute pitch-black water of the abyssal plain, illuminating a massive, ghostly titanium sail. This deep ocean phantom is the Soviet nuclear attack submarine Komsomolets, resting approximately 5,500 feet deep in the freezing waters of the Norwegian Sea. In April 1989, a devastating fire broke out in the aft compartment of the submarine while it was submerged. The intense heat compromised the internal pressure systems and forced the crew to surface, but the catastrophic damage ultimately flooded the hull, sending the most advanced, deepest diving combat submarine in the Soviet fleet to the ocean floor. Today, it sits largely upright in the dark, acting as a hazardous vault holding 1 nuclear reactor and 2 reported nuclear-armed torpedoes. The boundary preventing the recovery of this radioactive hazard is the absolute technological limit of deep-sea salvage. While the unique titanium hull was strong enough to survive the crushing pressure of the descent without imploding, the intense heat of the initial fire and decades of deep ocean exposure have severely degraded the internal seals and containment structures. A full recovery of a compromised 8,000-ton nuclear submarine from that extreme depth has not been treated as a safe or practical response because the operation could destabilize the wreck and create a greater radiological and mechanical hazard than continued monitoring. The hazard is not dormant. In 2019, Norwegian marine scientists deployed a deep-sea remotely operated vehicle to survey the wreckage and detected elevated cesium-137 near an open ventilation pipe. The release appears sporadic and highly diluted in the surrounding deep water, and researchers have continued to study exactly how radioactive material moves out of the wreck. Because the depth rules out ordinary human intervention, authorities monitor the wreck by sampling seawater, sediment, and organisms growing across the titanium hull, including deep sea life that can record contamination over time. We often view modern salvage technology as an unstoppable force, operating under the assumption that any shipwreck can be raised if a government is simply willing to spend enough money. These 5 underwater sites prove otherwise, showing us that the ocean does not automatically erase our most dangerous creations, nor does it easily surrender them. Instead, it holds them in a volatile state of suspension. The rusted masts still break the gray waters of the Thames Estuary. The rainbow-colored oil still bubbles up from a sacred memorial in Pearl Harbor, and radioactive traces are still measured in the total darkness of the Norwegian abyss. If you want more stories about the unresolved mysteries of the deep, let me know which shipwreck I should cover next. Sometimes the most difficult thing for an engineer or a government to accept is that the safest answer is not full recovery, but limited intervention, containment, monitoring, and the discipline to leave the main wreck where it fell, knowing the story of the ship will never truly be over.